Yes.
It was 3. The absolute value 1 minus x over 4 minus 2 greater than or equal to 10. And if you remember, this is an absolute value inequality. And first of all, we have to clean it up. I will add 2 and divide by 3. When I add 2, I get 12. When I divide by 3, I get 4. So it changes into 1 minus x over 4 greater than or equal to 4. And now I have to remember that this is not a linear inequality. One more time, it's an absolute value inequality. I have to remember how to read it. And here's how I read it. I'm asked to find numbers whose distance from 0 is 4 units or more. There are only 2 options. I would have said, okay, there are 15 options. It's difficult to remember. There are only 2, right? So there are 2 options in the following way. Less than or equal to 4 or greater than or equal to 4. And if it's greater than or equal to 4, then they have to be further away. So it changes into, you can't do anything here. So this is it. You can touch it, you cannot distribute, you cannot multiply, nothing. Nothing can be done there. The only thing you can do is replace it by something else that we can solve. So one more time, it says greater than or equal to 4, which means this, not this. So you cannot put it as a chain. There are 2 different, totally separate. 1 minus x over 4 greater than or equal to 4. 1 minus x over 4 less than or equal to negative 4. Say it again, Ryan. That's okay. The classwork only is supposed to give you an idea of where you are and how much you still need to study. Okay, we all make mistakes. We learn. Okay, so now I can solve this and I can solve this. I'm going to subtract 1 from both sides, negative x over 4 greater than or equal to 3. I will multiply both sides by negative 4, x less than or equal to negative 12. The same thing here, I subtract 1, negative x over 4 less than or equal to negative 5, multiply both sides by negative 4, and of course I have to change the inequality symbol. So I have to have the union. Every time I have the outside, the solution has to have the union. Okay? So this one first, negative infinity, negative 12, and this one last. Thank you. Claudia, is this okay?
Yes.
Okay. Good. So just please pay attention. There are only 2 different types. Anything else? Is there anything else you would like to go back to? Tom?
Real quick thing.
Yes.
I just want to make sure that with number 1 on yesterday's classwork, that the only real thing I got wrong here was not only forgetting the equal 0, but also forgetting the factor that.
Right. So the problem is that once you forgot the equal symbol, you did not finish. You did not finish factoring. You didn't solve it.
Yeah.
Okay. So that's why I emphasize that so much. I know I sound like a broken record. I always say equal symbol 0, equal symbol 0. Yeah. Good. Anything else for me? Anything from anything? Anything else you worked on? Other questions? Other questions? Okay, let's go back to what we covered last time. And let's see if we have questions on that. Oh, really? Yeah, I didn't. Okay, got it. So we looked at functions. If we are given graphs, we can identify the graph that represents a function using the vertical line test. We identify domain and range. We determine the zeros or the x-intercept, same thing. Increasing and decreasing intervals. Local max, local min. Wake up, wake up. Why is it doing this? Okay, maybe if I do this. Ah, good. So increasing intervals. When we talk about an increasing or decreasing interval for a function, we are only talking about x, not from which value till which value. For example, somebody's salary increased between 2010 and 2017. We are not asked from which salary to which salary. We are only told find the trend. Between 2000 and 2010, the trend was increasing. Okay. We talked about symmetry. There are two different types of functions. Functions don't have to be symmetric. It's nice if they are, though. And we know there are two different types. The even type, that is symmetric with respect to the y-axis, and the odd type, that is symmetric with respect to the origin. Okay. And we looked at examples, and then I copied a graph from your book, and we answered a lot of questions about this. Symmetric, and then we looked at piecewise defined functions, and we graphed one piecewise defined function, or several, I don't remember right now, that's why I keep my notes. Okay, so that was a graph. No, we only looked at one. If you'd like to look at another, we can. And then we looked at the difference quotient. The difference quotient gives us the rate of change of a function between 2 points. So for example, let's say I get in my car now, and let's say I want to get to New York, 200 miles roughly from here, and you call me at some point in time and you say, where are you? And I'm going to say I'm in Philadelphia or passing by Philadelphia, and you say, okay, call me when you arrive. I call you when I arrive, and then you ask me, what was your speed between Philadelphia and New York? And I will say, well, I can only tell you an average speed. So I will calculate the average speed, which is nothing else but the difference quotient, and tell you what it is. If you want an instantaneous speed, then when you call me, you say, look at your odometer and tell me how much it is. And then I'll tell you the instantaneous speed. But if you want the distance, if you want a speed on a particular distance, I won't be able to give you anything else but an average speed. And that is an example of a difference quotient. Okay. And we looked at a difference quotient for two different functions, and we simplified it, and we said there were two pieces of very important pieces of information. One, for any function I determine the difference quotient, the terms at the top that do not have h must go away. Otherwise, I made a mistake somewhere. The second very important piece of information was that eventually the h in the denominator must go away. The final simplified form may still have h in it of the difference quotient. As you see, it does. But this particular one must go away. And also all terms that do not have h must cancel out with terms that do not have h and have opposite sign. So keep that in mind about the difference quotient. Two things. Everything that does not have h at the top must cancel out with other terms that are opposite sign. And eventually, this h in the denominator must go away with another one from the top. These are the two very important pieces of information about the difference quotient. The final simplified form can still have h in it. Okay. Then we looked at some, I think this was basically, not class work, but after class we stayed and we looked at a few problems. So I posted them as well. But the last 3 pages here were not part of the class. So this is where we ended with one function and determining the difference quotient. And we should look at another. Any questions from me? Any questions from anything you've seen? Anything? Okay, so here's the plan for today. I would like to finish, if possible, I would like to finish sections 2.3 and 4. They are basically review of lines, nothing else. I would like to show another example with a difference quotient. I would like to show another example with graphing a piecewise defined function. And hopefully I can start 2.5, which is the last section before we review for our first test. I already sent to the copy center a copy of for you of my previous test from chapter 1 and chapter 2, so you know what to expect. So on Thursday, we're going to start working on that. I'm going to give you a copy. Okay, so let's start with 2, 3, and 2, 4, and then come back with a difference quotient and the graph of a piecewise defined function. Is that okay? Yes? Okay. So let's look at 2.3 and 2.4 together. It's all about lines. This all review about lines. And remember, we have a race against Tom. So before he answers, we have to put in our thoughts quickly because he's so fast. Okay. So the equation of a line is y equals mx plus b, which we know how is this called?
Slope-intercepts.
Okay. So I will call it slope y-intercept just to be clear, but you're right. This is how it's called. It's the slope-intercept form. How do I know this is linear? Because x and y have power 1. And remember, no variables in the denominator, no products of variables. And we know that this is the notation for the slope. What does the slope mean? It's the steepness of the line. This line is steep. This line is not as steep. And it has a positive slope, right? This line is very steep, a negative slope. This one is less. Easier to walk on, right? So the slope, what does this represent?
We're on the x-axis.
Yes, the y-intercept, very good. And it's always 0, a number that is the y-intercept. So every time I'm given points, I will always look for this. Hopefully I get the y-intercept. Not necessarily, I may or may not. Okay. If I'm given 2 points, or also called ordered pairs. 2 points or 2 ordered pairs. Let's say x1, y1 is the first point. And let's say x2, y2 is the second point. So I'm given 2 points. How do I determine the slope of the line passing through these 2 points?
Rise over run.
Yes, rise over run. Rise means difference in what variable? Y. And run means? So what does this really mean? If I'm going up the hill, so between this point and this point, I basically go up some vertical difference, right? And some position difference. So that's what it is. So how do I write the rise?
y2 minus y1.
Very good. And the run, x2 minus x1. So this is one piece of information that is very important, and this is the second one when it comes to lines. Now, what if I'm given, or I have the slope and a point? So given the slope and a point, not the y-intercept. Not the y-intercept. What equation will I use to determine the equation of the line? What form will I use to determine the equation of the line?
Standard form?
I'll get to the standard form. Thank you for mentioning it. Yes, the point slope form. Very good. How do I write the point slope form?
Y minus y1.
Very good. Slope times x minus x1. Good. And now let's talk about the standard form, which I render useless. But since Tom mentioned it, I have to mention it now.
I was really just guessing.
I have to mention it now. Thank you very much for that.
AX plus BY equals C.
Yes. So it's ax plus by plus c equals 0, but you're on the right track. I consider this useless only because I can determine the slope. I have to perform some operations on it to determine the slope. I can determine the y-intercept. Again, I have to apply some
Really
operations
just
on
say
this.
if you want to ruin somebody's day when they're on a roll.
Okay, if you say so, that's good.
I mean, like, say you're blazing through a bunch of slope problems, then that shows up. Well, your streak's ruined, and now you got to take some time and figure out how to get this in the slope-intercept form.
Yes, yes, that's true. Well, we're going to use that in a minute to do that. Okay, number 5, types of lines. Therefore, should I shut the door? Does the piano bother you?
Not really. Not me, at least.
Everyone is okay with that? Okay, very good. So this is a nice trend. What type of trend?
Upward.
Yes, positive. It's a positive trend. So then the slope will be very good. Obviously, the other one,
Negative.
very good. This is what type of line?
Equals 0.
Yes,
And horizontal.
VS. And this one is what type of line?
There you go.
The slope is undefined, but the type of line is
Right.
vertical. Very good. And the slope equals undefined, which means it does not exist. There is no slope. And item 6, as a review or refreshing your memory, and then we'll look at problems, is parallel lines, perpendicular lines. Two lines are parallel, and I'm going to graph two parallel lines right here. You can say they're not perfect. I would have to agree. And I'm going to graph two perpendicular lines that form 4 90-degree angles. 90, 90, 90, and 90. What is the relationship between the slope of the first line and the slope of the second line? They are, say it again, Brian?
Identical.
Yes, very good. Indeed, M1 must equal M2. This line has slope M1, this line has slope M2. They must be identical, otherwise the lines will not be parallel. Very good. What about this situation? Negative. Negative multiplicative inverses of each other. M1 will equal the opposite of 1 over M2.
Is that not inverse?
Negative inverse.
Negative
Oh,
inverse. Yes. Yes. So if two lines have their slope in this relationship, they must be perpendicular, and vice versa. If they are perpendicular, the relationship between their slopes has to be this. So for example, if the slope of one of them is 1/2, what should the slope of the other one be? -2. Right. What if the slope of this one is 2/3? What should this one be? 3/2. Right? I prefer, this is the relationship in most books, but the way I remember it, and I think it's easier, is I'm going to multiply both sides by M2, in other words, cross multiply. Here's how I remember it. M1 multiplied by M2 equals, that's it. So I think it's easier if you say the product has to be -1 than to say, okay, I have to use the multiplicative inverse and then multiply by -1. I think it's easier. If this one is 2/3, obviously this one has to be -3/2. If this one is 1, this one has to be -1. If this one is 2, this one has to be -1/2, so that the product is -1. Yes. Okay, so I think this is pretty much it. There is really nothing else about lines. So let's look at problems. I'm looking at 2.3. Let's say we want to look at problem 70 on page 267. We have 6x minus 3y plus 15 equals 0, and this is the typical situation for the standard form. We're asked to graph, and let me reemphasize the fact that the x and y intercepts are the most important points. Yes, I know you can graph using the slope, but this is the only graph that you can use the slope to graph. So it is wise to move away from that and always look for the x and y intercepts if they exist. Okay, so if I want to determine the x-intercept, what do I have to find? I should say no. How do I start? What do I have to do to find the x-intercept for any graph? I set
Y to 0.
yes. Do you all agree? With the x-intercept, I have to set y equal to 0?
Yep.
Okay, we know why? Because the equation of the x-axis is,
X equals 0.
careful,
Y equals 0.
correct. The equation of the x-axis is y equals 0. Here's what I do. It's not necessary to solve for y. Don't perform any calculations. Okay? So when y is 0, this term is gone. So I have to solve the equation 6x equals 15. 6x equals negative 15. So then 6x equals negative 15. I divide by 6. And I have to simplify. What do I simplify top and bottom by?
3.
3. So then x equals negative 5 divided by 2. Please give me the ordered pair that we just determined here.
Negative 5 over 2.
Yes, very good. Is this okay, everyone? Stop me if you have questions, please.
What section is this?
2.3. Yes. So we are in 2.3 and 2.4, all about lines. Good. How do we find the y-intercept?
So x to 0.
Very good. Again, don't do anything. Don't solve for y. It's a waste of time. I cover it because it's gone. If x is 0, the term with x is 0. So then I have to solve the equation negative 3y equals negative 15. And that gives us y equals,
5.
and the ordered pair is,
0, 5.
that's it. That's all we need. So let's graph, connect the points, extend the line, and this is it. In order to plot negative 5 halves, comma 0, that's negative 2.5, comma 0. Right here. That's the x-intercept. And then 5. 1, 2, 3, 4, 5. Connect and extend. Always write the equation somewhere close to the line, so you know what you graphed. We graphed 6x minus 3y plus 15 equals 0. Again, there is no need to solve for y. It would be a waste of time. Let's look at 32. Any questions for me, please? Any questions? So this is basically graphing using x and y intercepts. In 32, we are given 2 points. We are given negative 3, comma 6, and we are given 3, comma negative 2. We're asked to find the equation of the line passing through them. So what should I do?
Calculate the slope.
I have to determine the slope. Very good. I will label my points. I will label x1, y1, x2, y2. You can do vice versa, it doesn't matter. The slope of a line or the slope of a hill going up or down it's not going to change. I write the equation. I will always write y2 minus y1 over x2 minus x1 just to make sure I don't make a mistake. Then I will replace them clearly and I should say slowly. Negative 2 minus 6, but 3 minus negative 3.
3 plus 3.
Correct. The numerator is Careful.
No, that's
Negative 8. The denominator is 6. The answer must be negative because the, yes, and we simplify by 2 and we get, sorry, I said 2 and I wrote 2. So it's indeed negative 4/3. Now I look at the 2 points and I realize that I do or I do not have the y-intercept. I do not.
yeah,
No point is 0 comma a number. So then I will have to use the point slope form. I will write the equation again so I don't make a mistake. So y minus y1 equals the slope times x minus x1. It doesn't matter which point you use. I will use my x1, y1 just because I want to, but you don't have to. You can choose the other one. I will write underneath those variables. They're not variables, those given values, negative 4/3. And after I position them underneath the information I have, then I will rewrite the equation slowly, putting the numbers in. So I have y minus 6 equals negative 4/3, and in parentheses x, I see a minus and a minus 3, plus 3. I have to solve for y. The first step would be to distribute negative 4/3 and then add 6. So when I distribute negative 4/3, I get this. Let's take this product aside. Negative 4/3 times 3/1. I simplify. I always simplify before multiplying. So what do I get when I distribute negative 4/3 to 3?
4.
Yes, but negative. Very good. And then I have to bring a positive 6. So then y equals negative 4/3 x and plus 2. So the question is, what does this represent? What does it represent? It's the equation of the line doing what? The equation of the line passing through the given,
y-intercepts.
the given
Points.
two ordered pairs or points, correct? Yes, this is the equation of the line and no other equation passes through these 2 points. Yes, because this is in the form of y equals mx plus b. I have the slope, I determined it a while back, but can anyone identify from here the y-intercept in an ordered pair format?
0, 2.
Thank you. We're getting better and faster, Tom. Are you happy?
Yes.
Good. Any questions for me? Any questions? Okay. I would like to look at problem 16 on page 279. We're given a function f of x equals x squared minus 2x. We are given x1, which is 3, and we are given x2, which is 6. Here's the question here. Find the average rate of change.
So an integral.
That's a limit.
Oh,
Nice. Find the average rate of change of f of x between points 1 and 2. And you should say, I don't see any point here. You only said x1 equals 3, and you said x2 equals 6. Anyone else but Tom? So can anyone decipher this for us and say, I mentioned points, but I didn't give you any points.
you have half of each point.
Thank you.
as well as
Okay.
the equation.
Okay. So what do we have? So I'm going to call this point 1. I'm going to call this point 2. What do we have from about point 1? What do we know about point 1?
X.
Yes. What do we know about point 2?
X.
Yes. Now the question is, I'm given a function, and I'm given x, and I want to find what?
Y.
Yes. Perfect. How do I find y corresponding to x equals 3?
Plug in X.
Thank you. So this is nothing else but f of 3, and we'll determine it in a moment. And obviously, this will be, it must be, f of 6. So let's review this for a moment. Every time I have a function, and I'm told here's x. In order to determine the corresponding y, I have to plug in x in the function. Is that clear, everyone?
Mhm.
Yes, everyone? Okay, perfect. So let's plug it in. 3 squared is 9. 2 times 3 is 6. 9 minus 6 is?
-3.
9 minus 6. 3. Perfect. Now let's check, let's plug in 6. 36 minus 12.
24.
Good. So now the average rate of change is nothing else but the slope of the line connecting these 2 points. Like the difference quotient. Same thing. So the average rate of change of this function between points 1 and 2
1/7.
is nothing else but the slope is the average rate of change between 1 and 2. And you know what I mean by 1 and 2. So now the formula is the same, but we like to write it a little bit differently. F of x2, which we just did, minus what? Very good. Over,
X2 minus X1.
that's it. It's the same thing. But just instead of writing y2 minus y1, we write f of x2 minus f of x1 just to signify that we are really looking at an average rate of change. Good. So all I have to do now is just plug in the numbers. And the numbers will be 24 minus 3 over 6 minus 3. So
21 over
24 minus 3 is 21. 6 minus 3 is 3. And of course, Tom was right, 7. Now, remember the average rate of change, like the slope, has a measurement unit that is a ratio. So if I drive and you call me and say, what is your speed right now? I can say that I'm driving at 60 miles. It's the rate of change of distance with respect to time. Distance is measured in miles. Time is measured in hours. So I will say I'm driving at 60 miles per hour. Same thing here with the slope or the average rate of change. So if this is distance and this is time, I will have to say the average rate of change for this function between point 1 and point 2 is 7 miles per hour. So remember, the average rate of change has a ratio as a measurement unit. The measurement unit for the top over the measurement unit for the bottom. Okay, let's look at (12) on page 279. A line is passing through a point 5 comma -9 and is perpendicular. This is the mathematical symbol in which, in short, we say perpendicular to an equation, to a line whose equation is x plus 7y minus 12 equals 0. So one more time, we're asked to find the equation of a line. Let's say the line is this. I do not have the equation of this line. It's unknown. I'm asked to find it. And I am given 2 pieces of information. One piece of information is that the line is passing through this point. So somewhere along the line, I have this point that is 5 comma -9. It's part of the graph. The other piece of information is that this unknown line is perpendicular. In other words, it forms 5 90-degree angles to a line whose equation is given. So the green line is x plus 7y minus 12 equals 0. So one more time, I'm asked to find the equation of a line, knowing that it passes through this point and is perpendicular to the green line. What should I do?